All right, so I'm recording the solutions to the test. The retest is going to be on Friday, and then we will just continue to test this until everyone in the class has solved it. That's how important this stuff is. So I'm going to start with, here you can see I've made the table for you. I did that so that it should guide you through. So answering this question is going to help you with the rest of the test. It says Bobby solved the equation 2 times x minus 1 equals 1/2 times x plus 5 by entering the left side in for y1 and then the right side in for y2 and making a table shown below. You don't have to make the table yourself. It says using the table, what is the solution to the equation? Well, that happens right here where y1, this column, is equal to y2, this column. I'm trying to make the left side equal to the right side, equal to the right side. And that happens when this is equal to that, where 7 is equal to 7. That happens where x is 4. So the solution is x is 4. And then it says describe step by step how to make a table and use it to solve. Step 1, clear your RAM. You do that by pushing the seconds and plus buttons that take you to memory. Then option 7 to reset, 1, 2. Okay, so first you clear your RAM every single time you get the calculator. Second, you push y equals and put in the functions y1. y1 is this side, 2x minus 1, and y2. y2 is this side, 1/2 x plus 5. Step 3, push seconds and graph. Now, when you push the second button, it gives you the yellow command, which above graph is table. So second and tapped graph will take you to the table. And then look for what x value makes y1, the left side, equal to y2, the right side. In other words, you're looking for what x is going to make this equation true. The x that does that here is the number 4. All right, so let's move on to the graph. It says Janice solved the equation 2 times x plus 2 equals x minus 1 by entering the left side in for y1 and the right side in for y2, and she made a graph and it's shown below. It says using the graph, what is the solution to the equation? The solution to the equation is right here. It says that the intersection, you can tell the intersection is right here. That happens at negative 1, 2, 3, 4. The intersection is right here where x is equal, and it tells you right here x is equal to negative 4. So the solution is x equals negative 4. Then it says describe step by step. Well, step 1, clear your RAM. Step 2, push y equals and put in the functions y1 and y2, the left and the right. So this time I would put 2 parenthesis x plus 2 in for y1 and then just x minus 1 in for y2. Step 3, push graph. Graph being the button we're discussing here. Then graph would be here, and then second and graph would take you to the table. Okay, so let's go ahead and follow those steps really quick. So let's see, clear. We'll go ahead and clear RAM. So I'm going to go seconds and plus is going to take me to MEM memory. And then option 7, reset. Option 1, all RAM. Option 2, reset it. It says RAM cleared. I'm going to push y equals. I put 2 parenthesis x plus 2 parenthesis. And then x minus 1 is the next one. Notice that if the minus is in the middle, it's this blue button here. And then I can push graph. And the intersection is over here. I did something weird when I made this picture, because if you actually calculate the intersection, it's different, but that's okay. So option, seconds and calculates just above trace. That's where we are now. So seconds and trace is going to give you CALC for calculate. And you're trying to calculate the intersection. And then once you get to the intersection, it's going to say first curve, second curve, guess. So you have to push enter 3 times in order to get the intersection so that the screen looks like this. Okay, so that was clear RAM, push y equals, and put in the functions, then push graph, and then last step, push seconds and trace. That's going to take you to the calc menu. Choose option 5 for intersect, and then enter, enter, enter. All right, so last, you push second and trace. That takes you to the calc menu. Second and trace takes you to the calculation menu. Choose the intersection and then enter, enter, enter. All right, so let's move on to the next question, which was 5x plus 2 equals negative 13. And I'm going to choose red. Let's start with red. So I'm going to do algebra and a table and a graph. So I'm going to start with the algebra. 5x plus 2 equals negative 13. And then I need to put up my wall so that I don't mix up the left and the right-hand side. Now, I always divide last, so I'm going to remind myself that here. Divide last. So the operation that I use last in PEMDAS is going to be divide. That's going to be the last step. So this is 5 times x plus 2 equals negative 13. Now, do not move the 13 to the x. The x is going to be very upset if you move this 13 across the wall towards him. He wants to get things away from him. And then we can't move the 5 because that would be divide. And I remember that I divide last. So I'm going to subtract this 2 from both sides and then cancel my opposites. Negative 13 and negative 2 make a grand total of 15 negatives. Quit trying to remember rules. There's 13 negatives and 2 more negatives. That makes a total of negative 15. Okay, and then I'm going to bring down 5x on this side. 5 times x, I should say. Now the opposite of times is divide. Divide by 5, divide by 5, cancel my opposites, and x is here by itself. The wall gives me the equal sign, and negative 15 divided by 5 is negative 3. I'm going to put a box around my answer. Okay, and then I'm just going to assume that you guys can follow. Well, I'll just do it once. So let's see, y equals, let's 5x plus 2, and I'm going to push this delete button to get rid of the other stuff. And clear is going to get rid of everything at once. Now this negative in front of the 13 is this button here. There's a difference between the negative here and the minus here. Minus is when it's in between. Negative is when it's all by itself. Negative 13. I'll go ahead and show you what happens if I push minus. If I push minus, then it's going to give me what's called a syntax error. Syntax means that I typed it in wrong. The word syntax means the way that you typed it. So I'm going to go to push 2 for go to, and then the cursor will take me to the error. It's right there. It's the negative. And then second and table makes this table. You can see that the solution is not here, so I can either scroll down or up. Looks like I need to scroll up. It happens right here when the two sides are both equal to negative 13. So the table for this one looks like this, and then I will circle the solution, which is where y2 and y1 and y2 are equal, which happens right here. I wonder if I can highlight that better. Which happens right here. Okay, and I do need to put the solution at the bottom, x equals negative 3, or else I can't get points. I had a lot of people confused. I know the calculator says it's negative 5 right here. That's telling you where the cursor is. And that's not where these two sides are equal to each other. Please think about what you're doing. And then now I need to do the graph. And I can see that the solution, negative 13, that's below the bottom part of my range. All right, so if I push window here to get to the domain and range, again, the solution is negative 13. Down all the way to negative 13. So if I push graph, I wouldn't expect to see the intersect. The intersect is going to be way down here, and it only goes down to negative 10, so I need to change the range. So which one of these am I going to change for the y-axis? I want it to go down to negative 30. Looks like this one. Oops, this one here. So let's go down to negative 15. That should see it. Okay, now when I push the graph, this is negative 13 here, 14, 15, and so I can see the intersect. And as you remember the steps to find the intersection? So it was second and calc. And then the intersection is option number 5. Enter, 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 and I get the intersection as x equals negative 3, which makes perfect sense. It was supposed to be negative 3 the whole time. All right, so let's go ahead and graph this thing. And then I'm going to circle the solution here as well. I think pink would be a better color for this. Nothing better than pink. And then I can move my dotted line up to here, and that's not very good, but it can still show me that negative 1, negative 2, negative 3, x is equal to negative 3 was the intersection. Okay, so the solution is x equals -3 because algebra, when I get x by itself, it's equal to -3. X is equal to -3 because that's the x value that makes the left and right hand sides equal to each other. Here, let me prove that. 5 times -3. I'm just replacing, I'm evaluating the function for x equals -3. So 5 times -3 plus 2, well, that's -15 plus 2. And -15 plus 2 is, in fact, -13. Okay, so that's what the table is telling me, is that this side is equal to -13 when x is equal to -3. And then the last thing is that they intersect here where x is equal to -3. Next problem. Okay, so 10x plus 7 equals 3x minus 7. So I've still got pink here. 7 equals 3x minus 7. And put up my wall to make sure that I don't mix up the left and the right hand side. This time I need to move an x from one side to the other because there's two x's and they're both on both. There's an x on both sides of this equation. So I could either move the 10x over here or I could move the 3x over here. It's entirely up to you. I'm going to move the 3x onto this side, minus 3x. I do that by doing the opposite. This was positive 3x, so I needed minus 3x, which is obvious because 3x minus 3x is 0. Those cancel, and now I'm ready to move on to the next step. 10x minus 3x is 7. X is plus the number 7. The wall is the equal sign. The other side is -7. And now I divide last, so I can't cancel the times 7. I have to cancel the plus 7. The opposite of plus is minus. Big long line. Subtract 7 from both sides. Cancel your opposites. -7 and -7 are not opposite. They are the same. Things that are the same are just counted together. 7 negatives and 7 more negatives makes a total of, think total. When you look for add, just think total. Don't think add, subtract, think total. So the total of -7 and 7 more negatives is -14. And then the other side is 7 times x. I divide last. Cancel my opposites, and -14 over 7 is -2. Put a box around your answer. And now I'm ready for the table. So I'm going to pause it, put it in. All right, so I stopped here at the minus symbol to emphasize that this is 3x minus 7. So I'm going to push the blue button. 3x minus 7. Now let's see what would happen if I push the negative and tried to push a graph. It messes everything up. So it does have, it's not going to throw an error in this case. It's just not going to be right. So 3x minus 7. And then let's look at the table. The table, these two are equal here, where x is equal to -2. So I can put this here. All right, and that happens when x is equal to -2. Once again, please do not be fooled by the fact that the calculator says x equals -3. X equals -3 is not the solution. That's where the cursor is. All right, and so the solution, just like I would expect it to be, because I know x is equal to -2, is x is equal to -2. And then the last one, I would push graph, and then find the intersection, and the intersection is again here at x equals -2. All right, I'm done with that one. Next problem. This one is a big, long problem, and so I'm actually going to put all of the algebra on just one slide here, so just a second. All right, so I made a dedicated space here for solving this with algebra, but actually I'm going to do this with a table and a graph first. So I'm going to switch the order in which I do things. Every method is good for a different thing. Algebra is the easiest here, and I would do algebra first and then use that to double check the other two. But for this one, I would do the table first and use that to double check. So here's what I get when I use the table. Let me put that in a calculator. Actually, I'm about to run out of time here, so let me stop this recording and I'll come back with number 3.